We're done till last class, right? Last Tuesday.
Today's class will not be in the quiz. Okay.
Okay.
So whatever you learned from up to last class will be in there. Okay. So Keynes' absolute income hypothesis says income increases, consumption increases. Income increased by $1, consumption increased by less than $1. This relationship between income and consumption can be written in a mathematical function where x is denoted as income, y is consumption, then y is a function of x. So it's a mathematical function derived from the economic theory. Always remember this. Whatever econometrics you are doing, you try to base on some economic theory. So economic theory is this absolute income theory, and we wrote it in a mathematical function. Y is a function of x. And obviously, we can say one more thing. What is one more thing? dy dx. Oops. dy dx equals what? Is what? According to Keynes? Hello?
Yes, Professor.
dy
It should
dx.
be f prime x.
Yeah. What will be the sign of this?
Positive slope.
Yeah. It will
Positive.
be positive. Also, we know that basically this is what is trying to tell you, okay? dy dx lies between 0 and 1. What is dy dx? dy dx is MPC. Marginal propensity to consume. So this is what we know from the theory, and also we know that. So for now, here is the mathematical function. If x increases, y increases, and for this particular consumption theory, dy dx lies between 0 and 1. Then, if we assume, for simplicity, a linear relationship between x and y, for simplicity, linear relationship. So we wrote y equals beta 1 plus beta 2x. What is beta 1?
Intersect.
Intersect. And beta 2 equals dy dx equals slope.
Equal MPC.
E straight line. Okay. So far, this is what you get from mathematical economics. So what is beta 1? If x is 0, y would be equal to beta 1. When income is 0, consumption will be beta $1, which is also called autonomous consumption. And beta 2, which is dy dx, also called the MPC.
Professor,
Ah,
can I ask a question?
yes.
So, Professor, here you wrote if dy by dx is greater than 0
Hmm.
for the consumption function. What
Hmm.
happens if dy by dx is smaller than 0? Will the range still be the same?
If dy dx is less than 0,
Yes.
what does it mean for this consumption theory? You basically don't need this when you write this, okay? This is basically embedded here. Can it be that dy dx less than 0? No, not possible. On an average for a nation, it's not possible. With high GDP, you are consuming less? Huh?
No.
No, dy dx would be positive, but it's a positive fraction. It's positive, but it's less than 1. So it's basically between 0 and 1.
Understood, Professor.
Okay. All right. So let's assume a linear relationship, and we will keep assuming linear uh, for a long time until we can handle the nonlinear issues. So now we know beta 1, beta 2. We know if you know beta 1 and beta 2, you know the straight line. This will be a straight line upward sloping with a vertical intercept beta 1. Is it okay? If you were to draw this equation, you would get an upward sloping line with a vertical intercept beta 1, slope beta 2. So that's the thing we are talking about. This relationship, consumer theory, a straight line, X is income, Y is consumption, and we assumed a linear relationship, a straight line kind of relationship. Okay?
Professor,
Yes.
is the B1 must be positive?
Well, if you go back to theory, it it's a Keynesian theory. It's a short run consumption theory. In a short run, it has to be positive. But in the long run, it might be 0. Okay, theoretically speaking. But when you go for estimation, you will see weird things. You might find negative, but we'll deal with that later on. So consumption theories wise, you assume, can you consume negative? Let's say you don't have any income, but will you consume negative?
No, Professor.
No, not possible. Theoretically, not possible. Anyways, so let's start from here with this straight line equation, and let's now think about so this is so-called two variable regression model, and we will focus on, so here is the example from the book. Okay, example from the book. Remember that consumption here in the book, they are giving you an example of weekly family income and weekly family consumption. How many families are there? A total of 60 families. So we'll, in a while, we'll show you the table. That's the whole point. So Y is consumption, X is disposable income for families. How many families are there? 60 families. And the families are divided into 10 groups of approximately same income level. Okay, so the families are divided into 10 groups by income. What are the income groups? 80, 100, 120, 140, and so on to 260. So these are the income groups from 80, 100, 120 up to 260. 10 income groups. And how many families are there? 60 families. Let's look at the table. I'm showing this to show you this table nicely. Can you see? Can you read? Hello?
Yes, Professor.
Professor.
Yes. So here, these are the all families in that locality. Okay, all the families. How many families are there?
60.
60 families. And income groups are here: 80, 100, 120, 140, 160, and so on. So here is X. These are X's. Here in this side, Y values. Y means family, weekly family consumption expenditure here. Weekly family income on that side. Listen carefully. Now you found that there's 1, 2, 3, 4, 5 families within the income group 80. How many families are there in the income group 80? 5 families. A total of 5 families. And if you ask, will the 5 families tell you same expenditure?
No.
No. So look at this. Here one family is spending $55, another family 60, 55, 70, and 75. Okay. Another family, another group of 100. Income group 100. How many families? 6 families are there. A total of 6 families. And their expenditures are different: 65, 70, 74, 80, 85, 88. Interesting. Let's say another one here: 140. 1, 2, 3, 4, 5, 6, 7. Income group of 140, there are 7 families and their expenditures are different. Okay, so think about it. Family with an income of 80, one family is spending $75. Another family is spending $70. And you go to another income group 100, to your surprise, some family is spending only 65. And then here, another family is spending 70. So where is the relationship? Here, one family with income 80 spending 75. Here, another family with income 100 spending only 65. Think about it. Or look at this. Income group 120, our family is spending 94. However, when income increases 140, our family is spending only $80. So, where is the relationship? Remember the relationship? X increases, Y increases.
Yes.
Keynes says if income increases by $1, Y increases by, consumption increases by less than $1 increases. But when you go and you look at a hypothetical example, but it's true in reality, that here are 5 families with income group, with income 80, one family is spending 75, another one here with income 100 is spending only 65. Then that's a big problem. So now the question is, what is happening? Where is the relationship between X and Y? Then obviously you look at other things. Now, if I ask, remember there are all the families here, all families, I repeat, all families of income group 80 are reported here. With income 80, this is Y. Y has 1 value, 2, 3, 4, 5 values. Then what is the mean of that Y? What is the mean consumption? When income is 80, different families are spending different amount, but what is the mean of that expenditure? Who can tell me? Hello?
So the conditional means?
This is obviously, conditional mean means when income is 80, okay?
Yes.
When income is 80, different families are spending different amounts. So what is the mean?
It's given 65.
How do you know it's?
It is written in the table.
Isn't
Conditional.
stable.
Median
But
number.
that's not the issue. But how do you find that is an important thing. The result is there, so it's the result. But how do you end up with 65?
Adding the income of different families divided by the number of families.
Okay, that's how you get the mean. Okay, any other thoughts? Any other thoughts? How do you find the mean? When income is 80, you see that Y has different value. What is Y? Y is consumption expenditure. Y has 5 values. How do you find the mean? Shamina Zaman. Shamina, are you there? Hello? Shamina? Maya? Maya Tuza Ong? Are you there, Ong? Hello, Maya? No. Sonam? Uden? Sonam Uden? Afia Akhtar? How do you find the mean?
Professor?
Yes.
Is it summation of X divided by N, that formula?
No. This is not a sampling mean.
Okay.
What is this? What did I say? These are all the values.
Yeah.
These are all the values with income 80.
Oh, so do we multiply like 55 multiplied by 80 plus 60 multiplied by 80, like that?
No. You use the, how do you find expected value of a random variable?
Summation xi into probability of xi.
Yes. That's why we spend more than a month to explain random variable distribution and all this. So anyways, I hope you will recall these things. We spend so much time on that. So here is a conditional mean. Is conditional means is saying when income is 80, then you see that y has many values. Actually, y has a probability distribution here. Even though it's 5, it could be 5 million values here. If you consider all the families with income 80, you will see that thousands of families have income 80, and there is a distribution of consumption. So when X is 80, there is basically a probability distribution of Y. It's a conditional distribution, and that distribution has a mean. That mean is reported here. Obviously, if you add and divide by 5, you end up with this same number, but you are using the wrong process. You are looking at a population mean. You just cannot add all of them, okay? So same here. If you say conditional mean of y given that x equals 100, then you find a mean from here and mean from there and so on. So all the means are reported here.
Professor,
Yes.
how did they find the conditional mean? I did not understand. What's the formula for finding it?
The same formula. The same formula. How do you find expected value?
By multiplying with the probability of
Yeah.
each.
So what is the probability of 55 here?
80?
Huh?
Is it 80?
No. 80
80.
is the value of x.
Is 1 by
There
5?
are two variables. One,
Okay.
x. X has these values. How many values does x have? 1, 2,
10.
10 values. Now we are talking about y. When x has a value of 80, then y has a probability distribution, and that distribution has a mean. How do you find, if you know the probability distribution, how do you find the mean?
By multiplying 80 with probability distribution.
The value of y multiplied by the probability of that value. So let's say y equals 55. What is the probability that y will be 55?
80.
Huh?
Is it 80?
How come it is 80?
Is 1 by 5?
It's 1 by 5, exactly, because there are only 5 values.
Okay.
It's 1 by 5 plus 60 multiplied by
1 by 5?
1 by 5, exactly. If two families had told you 60 and 60, then it would be, the probability would be 2 by 5. You know those things?
Yes.
Favorable cases versus total cases. So yeah, each case is equally likely here. 5 events, they are all equally likely. So probability of each value is 1/5. So you get 55 times 1/5 plus 60 times 1/5 and so on. And that way you get 65. How do you get this 77? When x equals 100, income equals 100, then y has a probability distribution. That distribution has a mean. That mean is 77. That is expected value of y given x equals 100. That mean would be 77, and so on. Question?
Professor, so
Yes.
while finding the conditional mean, conditional mean for the y values we are finding, right? Aren't we
Yeah.
using
Expected value of y
y?
given x.
X.
So expected value of y would be 65 when x equals 80. Expected value of y would be 77 given that x equals 100, and so on. So let's say 137. is a conditional mean of y. Expected value of y given what?
Y.
Huh? How do you get 134?
Given X is 200.
X equals 200. When X equals 200, then Y has a distribution. That distribution has a mean. Distribution means Y has many values with probability assigned. And then you get the mean. This mean is not X bar or Y bar. This mean is what? Expected value. Conditional, don't get scared by conditional. Conditional means is just saying what is the income. If income is 200, then one mean. If income is 260, then you get another mean. So on. That is the conditional.
Professor?
Yes.
Professor, instead of multiplying each weekly consumption with the probability, cannot we add the consumption then multiply it total? Cannot we add all the weekly consumption and multiply it by probability? Like 1/5?
If they are all equally likely, you can do that.
Like
but if they are not equally likely, then if they are not equally likely, then what do you do?
Professor, can you explain what do you mean by not equally likely?
What do you mean by not equally likely? When you toss a coin, head or tail, if the coin is fair, what is the probability of head and what is the probability of tail?
Half and half.
Are they equally likely?
Yes.
Yeah. Suppose you have a coin that you kind of tempered the coin and you said most of the time it shows head. Then what is the probability of head and what is the probability of tail? Are they equally likely? If you throw a coin which is not fair, most of the time it shows up head.
No, Professor, that's not equally likely.
That's not equally likely, yeah. So here is an equally likely thing. It's a kind of cookbook, okay? But in reality, when there is a income group 100, these values can occur many times, okay? Let's say 70. Suppose 70 occurs 3 times, but 74 occurs 5 times. Then will the probability be same?
No, Professor.
Then they are not equally likely. Here everything is occurring once, so they are equally likely, okay? If one thing occurs 3 times, another thing occurs 55 times, then they won't be equally likely.
Professor, how is it equally likely? Like, can you explain it a bit more?
Come on.
So, in this example, how is it equally likely?
So forget about others. Take this one, 80, okay? Income group, 80. What is the probability that the expenditure will be 55? If you draw a family from these 5 families, if you go and ask one family, what is the probability that that family spends 55?
1/5.
1/5. What is the probability that that family spends 65?
1/5.
1/5. They are equally likely. What is the probability that that family spends 75?
1/5.
1/5. That means they are equally likely. Equally likely means with same probability. The event can happen with same probability. They are called equally likely. Let's go back to our probability review. Let's say you throw a dice. What is the probability that one will show up?
1/2.
1/6.
1/6. What is the probability that 5 will show up?
Oh, dice. 1/6.
1/6.
What is the probability that 6 will show up?
1/6.
They are all equally likely because it's a fair dice. But when you go to village fair where they throw dice, they are not equally likely. Equally likely means occur with the same probability. So here, why they are equally likely? Because there are only 5 families, and 5 families they are spending differently. That's why. Let's change this little bit. Imagine, suppose 2 families are saying they spend $60. So instead of 65, there is 60. So 55, 60, 60, 70, 75. Then what is the probability that if you pick a family from that 5 families, what is the probability that the family will spend $60? Huh? Hello?
Till 1 by 5.
1 by 5? There are 2 families spending $60.
Okay, then
By
2 by
5.
2 by
5.
5. What is the
By 5.
probability that the family you pick spends 55?
It should
Huh?
be 1 by 5.
1 by 5, 1/5. What is the probability that the family spends 70?
1 by 5.
Also
1 by
1 by
5.
5.
So 60 and 55, 60 and 70, they are not equally likely. Because this is more likely. 60 is more likely. When you pick a family, that you pick the family with 60 is more likely than you pick the family with 55. Equally likely and more likely or less likely. Less likely means probability is less. More likely means probability is higher.
Professor, sorry to interrupt. Can you explain it again? I was not able to hear it because of network problem.
Okay, equally likely. Equally likely means events with same probability. I thought you understood this thing when we were reviewing statistics. Probably equally likely just is telling you that these events might occur with same probability. More likely means with a higher probability. Less likely means with a lower probability. So here what we are saying is this all 5 families, they are spending different amounts. So if you go take a sample, we pick up one family, what is the probability that that family spends 55? The probability would be 1/5. It's like a dice with 5 sides. In a dice, you have 6 sides. Here you have 5 sides. So you throw it, each of the side has equal probability. But if think about if 2 families were spending same amount, 60 and 60, then if you go and pick a family, that family probability that that family spends 60 is with a higher probability, will be 2/5, not 1/5 then. Then 60 has a more probability, more likely than 70 or 55 or 75. That's what I'm saying. Question?
Professor,
Hmm.
Professor, if we, for example, if we take the weekly income for 140, then the probability, then the probability for that row is going to be 1 by 7.
Yeah, here let's say probability of 103. What is the probability of 103? Yeah, here is also all equally likely here. Here, what is the probability that probability of 103?
1 by 7.
1 by 7.
Into 1 by 7.
If there were 2 103 or 3 103, then that event would be more likely than the other ones. But here they did it very simply, very simple way, so that you can see what's going on. But remember, when they are doing the mean, they are taking the expectation. That's not, what you're saying is not that important. They are equally likely or not equally likely. We know how to find expectation, don't we? Huh?
Yes, Professor.
For discrete random variable, we know how to find the expectation. For a continuous random variable, we know how to find the expectation. We didn't ask whether the events are equally likely or not. We just use the formula. Here they did it discrete. It could be continuous. Then you have to use the continuous formula to find the expectation. Anyways, it is a discrete because for simplicity, nothing else. Later on, when they do the graph, they will show a kind of continuous function. The whole point here is, if you have an x value, like say 80, then y has more than one value. Y has many values with probability assigned. Equally likely or not, that's not an issue. The issue is y has a distribution. And if y has a distribution, meaning y is a random variable, then that has a mean, which is called conditional mean. And if you look at the means, conditional means, then you see that as x increases, you see, as x increases, the mean values are also increasing. Do you see that? Huh? Hello? As x increases from 80 to 100, conditional mean increases from 65 to 75. X increases from 100 to 120, conditional mean increases from 77 to 89, and so on. X increases from 80 to 260, conditional mean of y increases from 65 to 173. So the relationship is actually between x and conditional mean of y. You agree? Huh? Hello?
Yes. Yes,
So this is how, you know, we explain things. So really, the relationship is between x and AC. Here they are giving the probabilities. Look, do you see the probabilities here? Conditional probabilities, 1/5, 1/5, 1/5, so on, and then you get the conditional mean. So conditional expectation is expected value of y given x equals a particular value. Value means 80 or 100 or 120 in our examples. So here you see, here. Now they are saying, look, when x equals 80, here is x and this is y. This thing looks ugly. However, I'll try to explain. So when x equals 80, how many values of y you get? Huh? 5 values. So they're saying, let's relax that. If there are 5 values and there is a mean, what is that mean? 65. Remember the conditional mean is 65? Yeah? So they put it here. Here. 5 values with different probabilities and you get the conditional mean, which is 65. And then when it is 140, conditional mean is 101. And when it's 220, the conditional mean is 149. So what they did is they added all the conditional means and you got this line. Question. Hello?
Yes, Professor.
Yeah. Any questions how they are drawing this line?
Professor, I did not understand.
Okay. So if x equals 80, what is the conditional mean of y? 65. Okay.
Okay.
They plot it here. 80 and 65. Remember, 65 is the mean value of y. When x equals, so they picked only 3. You could pick all 10 here. So they picked 140. If x equals 140, what is the conditional mean of y? Is 101. They put it here. If x equals 220, then conditional mean of y is 149. Picked it, plotted it here. So they plotted all 10. Let's say all 10 you can plot here from 80 to what was that? 260. You plot all of them here. So you see 65, 101, 149. They picked some of them. You could pick all of them. So you got 10 points, all 10 points, and you add the points. You add the points and you get this conditional mean of y. What is the height of this line? Straight line. Hello? What is the height of, huh?
This one.
What is the height of this straight line telling you?
Professor, which one? The diagonal one?
No, the one upward sloping.
Yeah, it's upward sloping.
Yeah, that's the line we are focusing on.
Oh, yeah.
What is the height
It's
of that
saying-
line giving you?
It's saying that if...
No, just give me the height. What is the height of that line?
220.
Huh?
220?
No, I'm not asking for value. I'm saying any point on that line. What is that height? Height means the vertical distance. You see this line? Can you see this line?
Yes.
Professor.
It's an upward sloping line. Okay. And it has an intercept here. If it's a straight line, it also has a slope.
Yes.
What is this height? What is this height?
Okay, 65, 101,
No,
140.
I'm not asking for the value. I'm
Sir,
telling you what are they?
It's the
Eh?
consumption.
They are
Consumption.
they are this expected value of y, but it's a conditional expectation. They are the not consumption. They are mean of the consumptions. Are they mean, or they are individual consumption? Huh?
Mean of consumption.
Mean of the consumption, expected value of consumption. But expected value, whatever expected value, conditional. Conditional, don't get scared by conditional. It's saying when X is 80, when income is 80, then mean consumption is 65. So you plot that. When income is 140, then mean consumption is 101. You plot that. And then you add all of the conditional means of consumptions. You get this straight line. It's saying if X increases, conditional mean of Y increases. That means if income increases, conditional mean of consumption increases. So what is the relationship between?
Between consumption and what's that thing called? Conditional mean.
Consumption and conditional mean, what does it mean? Does it mean anything?
No, I mean to say the relationship between consumption and income.
That's what they're saying. That what was I trying to tell you here? If income increases, consumption increases. Can you see that?
No,
No. What do you see?
that there is a conditional mean.
What do you see? What kind of relationship do you see? Okay, one more time. Look at these values. What are these values?
These are income values.
Income values. What are these values?
Mean.
Conditional mean
Of what?
of income,
No.
of consumption, sorry.
Of consumption. There are two variables we are concerned with: income and consumption. So the whole story, if you don't miss, obviously income here, 80, 100, 120. Then we saw all these weird things. High income, low consumption, low income, high consumption, and so on. But at the end of the day, we found that if income increases, these things increase. What are these things? Huh?
The conditional mean increase.
Mean of what? Consumption. If income increases, we don't know what's happening to consumption themselves. Individual consumptions, we don't know. But what do we know?
Professor, how do we denote that?
Huh?
We will denote that the relationship between them are positive or upward sloping.
Them means who and who?
Conditional mean and consumption.
No, you are again going back to the same issue. Here is income, here is consumption. Conditional mean of what? What are these values? Let's say 65. What is 65? Huh?
Consumption.
Conditional mean of consumption.
Conditional mean of consumption.
When x equal to 80.
These are all conditional mean of consumptions. What are these values?
Income.
Income values. Now you see again, please don't say consumption and conditional mean. No, income here, increasing 80, 100, 120. We don't know what's happening to individual consumption. It's a mystery here, mysterious. But we know that if income increases, conditional means of consumption increases. And that thing is reflected here. Look at these points. What are here? Huh? In the
Income.
horizontal? Income. What are these points? The height of these points. This height. What is this height?
The height is mean.
You just say mean doesn't mean anything. Mean of what?
Okay. Consumption. Mean of the consumption.
What type of mean?
It's the conditional mean.
Conditional mean of consumption. So what is this? Another conditional mean of consumption. What is the condition? Condition is x equals 140. What is this? Another conditional mean of consumption. What is the condition? Condition is income is 220. So all the points on this line are what? The height of this line? Huh? These heights, what are they? Huh? Now I'm coming back to the same point, same question. What is this height?
It's maximum of consumption.
Is the conditional mean of consumption when condition is x equals 80. Another height, conditional mean of consumption given x equals 140. Conditional mean of consumption given x equals 220. Any height of this line, is conditional mean of y given x. X means x different values. So now what we can say, I'll not ask anymore. I think asking is confusing you. So the relationship is showing that if x increases, conditional mean of y also increases. Once again, if income increases, conditional mean of consumption also increases. That is given here in this straight line. Okay. So the relationship is between which two variables? Hello.
Yes, Professor.
What is the independent variable? What is the dependent variable? Clearly.
The independent variable is income.
Yes.
And the dependent variable is consumption.
Consumption. You are again saying consumption.
The conditional mean of consumption.
Conditional mean of consumption. If you don't see that, then the whole point of regression is lost. Regression is all about average relationship.
Professor,
Yes.
why is it like that? Like, why is the dependent variable conditional mean of consumption and why not consumption? Because like in the graph, it's written weekly consumption expenditure, like on the y-axis, right?
These are all consumption values. But the line is on what?
Is on a height, which is the conditional mean of
These are the
consumption.
conditional mean. Obviously, this is the same dollar, but it's which dollar? The mean dollar. So once again, here is the whole point of regression analysis. Regression analysis is saying there is a relationship, true, but really the relationship is not between X and Y. However, the relationship is between X and conditional mean of Y. Let me, 2-minute digression, okay? I think I told you this story earlier. There's one big guy who got Nobel in economics, and his Nobel speech, he says, oh, I read this, so they were asking why he studied economics and all this. And he said, in social science, it looks like economics is the only subject that somehow tries to predict. What kind of prediction? Prediction is like, okay, so he talked about the foundation. I told you about foundation, the ultimate fiction. It's a science, also social science fiction. Foundation, you Google it later on, okay? The foundation, and you will see that in that series, there are a lot of books. People talk about foundation world and all this. In that world, there was this guy, he invented a branch of mathematics, and he called it psychohistory. And he said, we can predict mob. We can predict when there are a lot of people, we know how they are going to behave. But an individual person, no, it's very difficult to predict an individual's behavior. Okay, so that is this so-called foundation. So he used a very fancy mathematical model to predict a large number of people, basically saying I can predict the average behavior, average people's behavior, but one individual will be too random. So here in the econometrics, basically what they're trying to say is an average behavior of people as far as consumption is concerned, or in any other theories. So the relationship is between income and average consumption. Average means here conditional mean of consumption. So that's that line. So if it's a straight line, it has an intercept, it has a slope. All right. What is the intercept? Here. Now look at this line. Can you see the last line here?
Yes.
So remember we started with y equals beta 1 plus beta 2x. Hello?
Yes.
And now you see that basically that is not y equals beta 1 plus beta 2x. Rather, this is expected value of y. Conditional expectation of y given x obviously equals that beta 1 plus beta 2x. So now you are looking at the most important thing in econometrics. You are saying the relationship is not between y and x, rather it's the relationship between expected value of y and x. And it's linear because we assumed it's linear. You cannot guarantee it will be linear, but we assume linearity. So if we go back, so this is the equation basically. This is the equation you are looking at. Expected value of y equals beta 1 plus beta 2x. I is just observation, don't worry about I. If I equals 1, let's say x1, then we are looking at 80, x equals 80. If I equals 2, then you're looking at x2, then you are looking at basically income equals 100 and so on. So if you look at this equation, and if you think of this, where is that? You look at this line. So what is this height?
This one.
This height?
Oh.
Huh?
Is it also conditional mean?
Obviously, this line is all what?
Under the.
This line is all conditional mean.
Yeah.
The height of this line is all conditional mean. So what is this height?
This height is also conditional.
Yeah, true. But do you remember the equation?
Which equation?
This equation. Expected value of y, conditional mean of y equals what? Beta 1 plus beta 2 x. This is the equation that is drawn here. This is the equation. See, expected value of y given x equals what? Equals beta 1 plus beta 2 x. Now the question is, if you know that equation, what is this height?
The autonomous consumption.
Can't you see that is the vertical intercept of that line?
It is beta 1.
It is exactly.
Beta 1.
This is the beta 1. If you don't see that, you forgot your straight line equation. This is just saying expected value of y equals beta 1 plus beta 2 x. I is for observation, no worries. Then if I say, what is this?
Beta 1.
Beta 1. What is the slope of this line?
Slope is beta 2.
Beta 2. Intercept is beta 1, slope is?
Beta 2.
Beta 2. Everybody with me here? I cannot go further if you don't see this. This is that a straight line. The equation of that straight line is this. Expected value of y given x equals beta 1 plus beta 2 xi. Intercept beta 1, slope beta 2. Question?
It's clear. It's clear now.
Is clear now? This is a new thing as the econometrics way of doing things. So far you have learned all the theories. You said, oh, in price increases, quantity demanded decreases. Now what do you know?
If income increases, then
let's say law of demand. What do you say? Price increases, ceteris paribus, quantity demanded decreases.
Decreases.
Now what will you say?
We say that if income increases,
no
then
income. Forget about income. Demand side. I'm saying if price increases,
so
quantity demanded decreases, ceteris paribus. Now what would you say? Can you say if price increases, quantity demand decreases?
No.
What do you say?
If price increases, quantity demand increases.
Increases?
Is that so? I don't know. Like in this case,
okay. I see. No, what I was trying to make is, if price increases, we don't know what happens to individual demand. What we know is if price increases, conditional mean of quantity demanded decreases. Like here, if income increases, what happens to consumption? Do you know that?
No.
No. What do you know? If income increases, conditional mean of consumption increases. That is the relationship. If you don't see that, I stop here. I have to make you understand this thing here. If income increases from 80 to 100 to 120, we don't know what's happening to the individual consumption here. But what we know is conditional mean of consumption also increases. And then we said, okay, that means basically here, income increases, there is a line. We assume a line because it's a linear relationship. Expected value of y given x. Conditional minimum means of consumption also increases. It's an upward sloping line. What is the slope of this line? What is the slope?
Beta 2.
Beta 2. What is the intercept?
Beta 1.
1.
Beta 1.
So beta 2 is positive or negative?
Positive.
Positive. Income increases. Conditional mean
Increases.
of consumption also increases. How do you explain beta 2 then? So beta 2 is the slope of this line. How do you explain that?
If
Yes.
like if income increases by $1,
Yes.
then consumption increases by beta $2.
Wrong. We don't know about what's happening to individual consumption. Do you know?
No.
No, you are losing the main point. The main point is if income increases, we don't know what's happening to individual people.
Okay.
What we know is conditional mean of consumption also increases. I told you even the story of foundation. I said we cannot predict individual people, but we can predict the mob, the large number of people, or otherwise average people. On an average, how people behave. So there's the same thing here. If income increases, what happens to individual consumption? We don't know. But what we know is if income increases, conditional mean of consumption also increases. And that is this line. Now, if I ask, what is the slope of this line? You say beta 2, okay?
Yes.
Here. Then I say, interpret beta 2.
Yes.
Yeah, please, go ahead.
So if consumption increases by
No,
$1,
you are going the wrong way. How can you say if consumption?
sorry, if income increases by $1, then the conditional mean of consumption increases by beta $2.
Exactly. Conditional. So if income increases by $1, conditional mean of consumption increases by beta $2. Conditional mean, also roughly speaking, in literature, it's an average, on average. On average, consumption increases by beta 2 if income increases by $1. So once again, beta 2 is the slope of this line. And the slope is telling you this. If income increases by $1, on average, consumption increases by beta $2. On average means here, actually, conditional mean of consumption. On average consumption means conditional mean of consumption increases by beta $2. Any question? Any confusion?
No.
So how do you explain this height here? Hello.
Yes, Professor.
How do you explain
So
that?
when income is 0,
Yes.
then the conditional mean of consumption will be beta 1.
Exactly. So when income is 0, then consumption on average is beta 1. Conditional mean of consumption is beta $1. This is how you explain regression. People get sloppy. People say if income increases, consumption increases beta 2. You know that that is utterly wrong. Very sloppy. Regression does not know what's happening to individual. Regression only knows what is happening on average. Will you please remember this for the rest of your life?
Yes, Professor.
Okay.
Professor,
Yes.
can you go to the equation for this line?
Okay. Okay. Equation is here. Yeah.
Professor, is it x1 like after beta
No,
2?
it's
Is it
xi. I means, so if x, let's say I equals 1 means first observation. So what is the first value of x in our example?
80.
80. So that means when x equals 80. So here x equals 80. So it's saying this equation will give you a value of expected value of y when x equals what?
80.
80. If I equals 1, x equals 80. Then in our example, what will you get? The value here? If x equals 80, what will be this value? Left-hand value?
It will be 65.
Exactly. It will be 65. If I equals 2, then it is x2. Then what is the value of x2? Do you remember the table?
Yeah. X2 is 100.
X2 is 100. Then expected value of y would be
77.
77 here. So that's what that equation is. So don't get scared by this I. Okay. You have this beta 1, you have this beta 2, but we now know how to interpret beta 1 and beta 2. We don't say if x increased by 1 unit, y increased by beta 2 units. No, never say that. You just say this is an average result. What is average? Average of y. X increased by 1 unit, y on average increased by beta 2 unit. On average means the mean of y, conditional mean of y increases by beta 2 unit. So in literature, they call it on an average or on the average. That means you know what it is. Regression always do the average result. Never can predict the individual results. Not possible. So here, and that line is called population regression line. Which line? This
Upward sloping line.
This line is called population regression line. Population regression line is giving you for each value of x, the conditional means of y's are given by the population regression line. Now, our whole effort is to get this line, which is not possible. What is this line? How do we know this line? If we know this line, if we know beta 1 and beta 2, if we know the intercept, we know the slope, we know the line. Unfortunately, there is no way to find beta 1 and beta 2. So this line remains a mystery. This is so-called population regression line. We are looking for beta 1 and beta 2, not possible. So this line remains a mystery. And these beta 1 and beta 2, they are like, really, they are population parameters. Beta 1 and beta 2. Remember the population parameters we talked about?
Yes. Yes.
Give me some population parameters.
Mean, variance,
Mu, sigma, population mean, not the sample mean.
Yeah.
When you say mean, careful, okay? As a population mean mu, population variance sigma square, population standard deviation sigma. These are the population parameters. These beta 1 and beta 2 are like population parameters. Now, it's econometrics job to find something close to beta 1 and beta 2. Okay?
Yes.
Okay. All right. So let's go ahead and check what they have in their mind. I would have rather other things. Okay, let's see then. Let's start the other one. So here is it.
Professor,
Yes.
what about PRL?
Huh?
PRL?
P or L?
No, like in the graph, like beside the graph, it was written like PRF, and there was another thing called PRL.
Okay.
So I was wondering what is PRL?
Okay, which one you were talking about? Let's see. Here?
No, in one of the slides. I think beside the graph.
Here? PRF?
No, that graph.
PRF? Here?
Here.
Okay.
PRL.
Okay, okay. PRL. There is the population regression line. So that is this line, okay?
Okay.
Population regression line. This is the line. PRF means the function itself. So when you are writing an equation, that is the population regression function. When you are drawing it, what is it?
Population
Regression line. That's the same thing. That's the same thing. Is it the height of expected mean? The height is the expected mean of y. All right. Let's see. I will not go into the meaning of linearity. Here is what we are trying to see. Now, if you recall the line and the individual values of y. So individual value, how many values when x equals 80, how many values of y you got? 5 values. Remember those 5 values? Remember them. 55, 60, 65, 70, 75. Very nicely, kind of in very nice order, so you can recall. Now, think about it. How do you find all the individual y's if x is given? If x is given, from this equation, expected value of y, you get the conditional mean, okay? Just focus on first column, x equals 80. What is the conditional mean of y?
65.
65. So x, if I give you x, you can give me the conditional mean of y from that equation, if beta 1 and beta 2 are known, obviously. But there are 4 more values. How do you find the other values if x is given? Huh?
By adding u.
By adding u. So by adding a number or by subtracting a number, depending on whether the y is more than conditional mean or y is less than conditional mean. So let's say a value 55, x is 80, conditional mean is 65. How do you get 55? Huh? Y equals? How do you get y equals 55? You subtract 10 from conditional mean. What is the conditional mean? 65. What is the y value? 55. How do you get 55? Conditional mean 65 minus 10. Are you with me here?
Yes.
So here, that's what they're saying. How do you get y1 equals 55? y1 equals 55, you get it, the conditional mean, beta 1 plus beta 2, 80, plus u1. But what is the value of u1 here? Huh? What is the value?
Minus 10.
Minus 10. Exactly, minus 10. Y2 equals 60. So the first part, beta 1 plus beta 2, 80 is the mean. And you subtract what? 5. 5. So u2 would be minus 5. How about this line? Y3 equals 65. The first part is the mean. Beta 1 plus beta 2, 80. What do you add with that?
0.
Huh?
0.
0, yes. And here, if it's 70, you add
Plus 5.
5. If it's 75, you add 10.
10.
So U has 5 values basically. Here is minus 10. U2 is minus 5. U3 is 0. U4 is plus 5. U5 is plus 10. So U has 5 values. How do you get individual Y? You get individual Y by adding or subtracting some numbers, and that some number is called U. So here, individual Y is expected value of Y plus U. But when you say plus, it can be negative also, depending on the value of U. U can be plus, U can be minus. So this is how you get individual Y from the mean of Y. You add some value or you subtract some value from mean. Then you get, yeah.
Professor, why do you subtract minus 5 there? Like U1 is
So
what?
what is the value of this part? Beta 1 plus beta 2, 80. What will be the value of this? Is the conditional mean. Do you see that this is the conditional mean? This part?
Yes, 65.
What is the conditional mean? 65. But individual Y is what? First Y is what?
80.
No, now you are confusing about X and Y. X is 80. What is Y?
55.
65.
55, it's here.
Oh, sorry.
What is the conditional mean of Y when X is 80?
65.
65. Then how do you get that individual Y value from the mean?
By
65 minus 55.
Minus, no, 65 minus 10. 65, the conditional mean minus 10.
Okay, sir. Okay, Professor. Now I got it.
Yeah. So from the mean, you can get each individual Y, either by adding some value or subtracting some value. Here in our simple example, we said expected value, this part, and you add a value U. But U can be plus or minus. When you are looking at Y equals 55, you subtract 10 from the conditional mean. When you are looking at Y equals 70, then you add 5 with the conditional mean. Conditional mean is 65, you add 5. So U4 would be plus 5 here when Y equals 70. Question? Hello?
yes, Professor.
Question. How you end up with this equation? Y equals beta 1 plus beta 2x plus U. How you are adding this U? When you want to know individual Y, you add this U term with the conditional mean beta 1 plus beta 2 xi. There are two parts of Y. One part is the conditional mean and another part is U. U can be positive or negative. Tell me if you understood this part and we will call it a day. how
Yes.
you are getting individual y from conditional mean. So if you understand this, then if you were to write the equation yi equals what?
Hmm. Y equal to expectation of y xi plus minus ui.
No, you don't have to write plus minus. You can be plus or minus.
Okay.
Okay, you itself can be plus or minus. So this is how you can write.
All right. Yes.
So I'll write a complete plus u, and I'll give all those i's. Remember, i's are nothing but the observations. If I equals 1, you are looking at x equals 80. So this is how you write, okay? Can you write like this?
Yes.
Do you see the difference between this and that? Forget about i's.
Yeah.
Here you had one-to-one correspondence, one-to-one relation between x and y. X increases, y increases. X decreases, y decreases. And with a long story, we are telling that that's not true. If x increases, we don't know what's happening to y, but we know that if x increases, conditional mean of y is increasing. Then we said, how do you find then a relationship between x and y? There is no straightforward relationship, but if you add a u with that, then for x value, you can find all the y values. How are you getting all the y values? You are either adding something with the mean, conditional mean, or you are subtracting something from the conditional mean. And that something is we are denoting by u. So that u is called a stochastic term. U is called a stochastic term, a disturbance term, a random term. It has many names. This is a key variable. U is a stochastic term, disturbance term, random term, white noise, so on. Any econometric model you are writing from now on, never forget to add this U. I repeat, any econometric model you are writing, never forget to add this U term, a disturbance term. Without a disturbance term, there is no econometric model. No econometric model without a U term. You write an econometric model without a U term, I'll deduct 50% of the points. No kidding, but I penalize you heavily because there is no econometric model without a disturbance term. If you write this, gross mistake. Any question? Hello? Do you have any question?
No, Professor, it's clear for me.
Okay, all right then. So I'll call it a day today. Don't forget our quiz is on Tuesday. In the class time, it will be short quiz, maximum 40-minute quiz, but it will be a closed book. But you can bring your statistical tables, and if you want some formulas, you can write 5 formulas maximum. You can write your formulas and you can look at the formulas. Okay?
Professor,
Not open book. Not open book.
Professor,
Yes.
can we write the answers on paper and scan it and send it to you?
Yeah, that's what you do. Last time, you write it on a paper, notebook, your paper, write with a pen. Scan it, make a PDF and email back to me and to the TA. All right? Question?
Professor, can you send us the Z value chart?
What chart?
The Z value.
Huh? No, you have, it's in the back of the book.
Okay.
You use your table. Don't ask me how to read the table. We spend so much time on reading the table. All right then. Can we now leave then? Hello?
Yes, Professor.
All right. Good luck with the quiz. See you on Tuesday.
Thank you, Professor.
Yeah. Bye-bye.
Goodbye.